see a message coming up at the top, I think, in a minute saying that you're recording. Can you see that?
Yeah.
Right, cool. Okay, so we're recording now. And I just want to get back to the screen where you can see my screen. It just take a few seconds. The other thing, well, I can't mute you guys. If you can try and stay as quiet as you can, that would be great, because then obviously it won't affect the video. So I'm just at the moment trying to get it. Here we go. So I'm just going to be able to get back to the screen. There we go. Lovely. Okay, so just to remind you all that this session, tree diagram. To what we did, what I did in the other videos, we're basically just using the same slide. So it's just an opportunity to bring it back, fresh in your memory. So, so this is the first question. So, no, I'm just going to skip the frequency. Get straight into the okay, so this is the first one we're going to do. So again, it's you, Poppy, playing cricket. So if you could all just make a quick note of this on the side, all right? So we got the probability that Poppy's playing cricket in the morning. The chances that she wins is 3 out of 5. In the afternoon, she's going to go and play a rugby. The probability she wins that. And then we're going to try and work through the probability tree and then just answer those 3 questions. So I don't mind, you don't have to copy out the question because obviously you can see it on the screen. Excuse me. If you can just go and get some paper and just try and remember what's going on here. I mean, I'll do this one quite quickly to model it for you, but it would be good if you're just trying to think ahead and you can just predict what I'm just about to do. All right. So if you remember, what goes on here is that we start off with the first event. So this is Poppy playing her cricket. Okay. So this is the cricket. And the probability that wins at cricket is 3/5. So if we say this is wins, the probability she wins is 3/5. So call it out. What's the probability going to be that she loses? 2/5. You've probably all muted your microphones, which is fine. That's a good idea. The probability she loses is 2/5. So that's the morning event. We then move over to the afternoon when she's playing her rugby. So let's then just go and extend our probability tree diagram to the afternoon, the rugby. And if you remember, in the afternoon, for these earlier ones, we just repeat the answers because how she gets on a rugby has got nothing to do with how she did in the cricket. So this is the rugby part of the diagram. And the probability she wins in rugby, we're told in the question. So the probability that she loses, because we're not allowing draws, must be the rest. So that's going to be a 7th. And then, as I said, this afternoon event that Poppy's doing, it is not affected by the cricket in the morning. So we just repeat these 2 probabilities down here. We have our 6/7 and the 1/7. So that then allows us to, that's a completed probability tree. We can now start answering the questions. So the probability she wins both matches. So she's got to have to win and then win again. Now she wins and then she wins. So we've got the 3/5 and the 6/7. And because this is an and situation, that's when we multiply. So she's got to win at cricket and Poppy's got to win at rugby. So 3/5 times 6/7. Remember, when you're multiplying fractions, it's just top times top, bottom times bottom. So that would be 18/35. And that's the only way she can win both matches. So that's the answer to part 1. Now, what about the chances of her losing both matches? Heaven forbid. So losing both matches, so that's a loss and a loss. So she loses and then she loses again. So that's 2 times 1, which is 2, 7 times 35. So 2/35. So that's the answer for number 2. Now, number 3 is the one you just got to be really careful with. Okay, so that she goes and wins 1, but she loses 1. Now, the question doesn't mind which way round. So maybe she wins at cricket, loses at rugby, or she loses at cricket, wins at rugby. But it's both of these that we're interested in. So you start off just working them out separately. So what's the chances of Poppy winning at cricket and losing at rugby? You do 3/5 times the 7th, which is 3/35. And then the other way that we can win one, lose one, is she loses and wins. So Poppy loses, and then Poppy wins, giving 12 under 45. Now, you've got to be careful here. That's 12 under 45. Now, we don't count which of these happens, whether it's this one or that one. Now, when you're saying or, you add them together. So we don't mind whether it's this or this. So we're adding fractions. Now, because the denominators are the same, that's easy. We just add the numerators, the top numbers, and that gives us 15 out of 35. So hopefully that rings a bell. So what I would like you to do, please. Okay, those are ones I just prepared in case my pen didn't work. So I would like you, please, to let me just have a yes. So what I would like you to do, please, is to have a go at the one on the left. All right. So this is Emma, where she's got 7 pens, 5 are blue, 2 are red, and we're just going to do a similar one to that Poppy example, please. Okay. So Emma takes a random pen from the box and writes it down its colour. Emma puts the pen back in the box. So that means these second ones are all going to be repeated. So please, can you just have a think about those, please? I'm just going to give you a minute or two to have a go at number 1 before I start going over it. I'm going to give you more time, but I'm just going to start filling in the beginning part just to make sure you haven't made a mistake really early on. You can hear that adder in the background. That's my wife next door. So, for part B, work out the probability that Emma takes exactly 1 pen of each colour. So that could be blue then red, or it could be red then blue. So how do we get that blue and red combination? That is 5/7 times 2/7, which is 10 over 49. So that was the blue and red. Now what about the red and blue? Well, that's 2/7 and 5/7. Which gives us 10 over 49. Now, the question's asking what's the probability that Emma takes exactly 1 pen pen of each colour. Doesn't matter which way around. It could be the blue-red combination or the red-blue. So we have to add these two together because we're thinking of it as a or situation. 10 add 10 is 20 over 49. So, shortly, when we turn over to page 7, on the left-hand side, you will have another one like this, where the second set of probabilities is a repeat of the first. But what I want us to do, I want us just to look at one of those trickier ones. So we're going to do the one on the right-hand side here. Now this was harder, and this is probably harder than we should really be doing in second form. But as I've said to you before, I really want to push you when I think it's something that you're capable of doing. So the one on the right-hand side, okay, the difference here is Emma does not put the pen back in the box. So we start off, I'm just going to get you going, we start off with the 5/7 and 2/7. But really, this is the key bit of the lesson. I want you to have a think about what probabilities we're going to put here and here, here and here. Okay, so I've put the little blue and I've put the blue things up here and the red things here to help. Okay, so these two here, that's going to be what happens when we take one of those blues away. When we take one of those blues away. Okay, so these two probabilities here will be when one of the blues removed. So have a think about that. And then down here, that's going to be when one of the reds removed. So what are we left with one of the reds removed? So I'm just going to give you a couple of minutes to try and fill in these probabilities up here, because this is the trickiest bit of the lesson. So just give that a bit of thought. I'd like to put me in a cup of tea, very nice. Okay, so first of all, when one of those blues has been taken, if the first pick by Emma was a blue, then clearly what are we left with? We're left with 4 blues, but it's 4 out of 6, not 7 anymore. Okay, so this probability here is going to be 4 out of 7. And what about, sorry, not 4 out of 7, 4 out of 6. What am I talking about? Sorry, 4 out of 6, that's the whole point. 4 out of 6, that's what we're left with. Here are our 6 that we're left with, and it's 4 out of 6. Blue, and 2 out of 6 for red. Okay, now what about though, if a different thing happened first of all? What about if Emma's first pick, her first pen had been red? So let's just take the red one out. So what are we then left with? The probability of a blue is now 1, 2, 3, 4, 5 out of 6. And the probability of a red is clearly just the 1 out of 6. Now that's the only difference, guys, taking that second set of probabilities. So for the answer for part B, it's going to be the same process. So the chances of Emma taking 1 pen of each colour, it could be the blue-red option, or it could be the red-blue option. Now the blue-red is 5, 7, 2, 6. Right, and remember, because it's a blue and then a red, we multiply. Remember, we multiply when we're thinking and in our heads. 5, 2 to 10, 7, 6 to 42. And then the red and then a blue is 2, 7 times 5, 6, which is 10 out of 42. And again, just like the same thought process for part. Okay. So we're just going to, because we don't mind whether this combination or this combination, we add these probabilities together, giving us 20 out of 42, which we could simplify, but we don't need to. So hopefully that all rings a bell. So to finish, I would just like you trying to do those to the answers. That's fine. I want you to do these. Now, do you remember the other lesson when I was pointing Josh with food? We've still got those little images up there when we were really looking forward to what we're going to be getting lunch. So anyway, so this is the final couple of slides, guys. So please can you work through the situation on the left when Matthew puts the counters back in the bag. So that's the easier one. And then secondly, on the right, when Matthew doesn't put the counters back. And so that obviously that probability there as well. So good luck. I'm just going to have my cup of tea and I'll be back with you in a minute or two.
Come on.
Okay, just going to do the easier one on the left. Just be really clear in your mind, because we're told that we put the counters in the bag again, that makes it one of the easier ones because nothing's changed when Matthew comes to take the second counter. We're still back to the situation of 3 reds and 5 blues. So that's why all these second lots of probabilities are repeated. Now, part B is easier now. We've just been asked to work out the probability. We'll take 2 reds and then another red. So 3 throughs are 9, 8 to 64. Easy peasy. So the trickier bit is what's going on with the second set of probabilities once Matthew puts the counter back in the bag. So obviously this top part of the diagram is when Matthew's taken red, first of all. So he's taken red. The first pick is a red. We're left with the probability of red being 2 out of 1, 2, 3, 4, 5, 7. 2 out of 7. 2 out of 7. The probability of the blue, taken to start with, is obviously 5 out of 7. Notice how the 2 numbers at the top of our always have the whole. Now, the second part of the program is when we assume that Matthew took the blue with his first pick. Put that back in. is taking the blue with the first bit, but the chances now, probably this is ridiculous. What's now the chances of him getting a red? But it's 3 out of 7, whereas the blue 4 out of 7. So then part B, probability that Matthew takes 2 reds, 3/8 times 2/7 goes 6 over 7/8. So that's it, folks. So I don't mind at all in a minute whether you guys want to hang around and have a chat. That's totally up to you. I will leave the meeting, but please don't leave until I've definitely switched the recording off, because it took me about 5 minutes to actually find the button to switch off last night. So just while I'm on the phone, I think on the laptop, there's two meetings tomorrow morning where everybody's just supposed to be touching base at 8:30. So Josh, hopefully you've got some coffee, and you should have got a little reminder through. So we'll just meet up for a quick chat tomorrow morning. So well done, guys. You were nice and quiet. Thanks for that. Just to finish, because whenever I go to this screen, I can't see who's there. So do you mind just quickly putting your microphones back on and just give me a shout out to who you are, so I can just remind myself who's actually been there throughout.
Poppy's here.
Poppy's here.
Josh is here.
Josh.
Casper's here.
Casper.
Emma's here.
Emily's here.
Was that Emily?
Yeah.
Cool. Well done, Emily. All right, guys. So well done. I think this worked okay. If you give it a few minutes and you look on Teams where the posts go, that bit where you're waiting for me to start the meeting, the video of this will be there in a few minutes' time. It just takes a few minutes to upload. But don't go yet. As I said, don't start yapping until you're absolutely sure that I've switched off the recording. So I think I've got to click this little button to see it's still clicking. Right, stop recording. Right. So let's just check stops recording. See, it doesn't stop. Oh, has it stopped? No, it's not stopping. It doesn't stop. It hasn't stopped. Stop recording, that's right. Oh, good.